Hi everyone, this is Zakir and this is the 8th video in our module Matrices. Check the description below if you missed the previous video. And in this video, we will be discussing how to solve a simultaneous equation using the inverse of a matrix. Any system of linear equations can be written in the form Ax equals b, where A is the matrix of the coefficients, X is the matrix of the variables, and B is the matrix of the constants. The algebraic properties of a matrix can be used to solve the equations. Let's take this system of equations. These can be written in the form Ax equals b. So that would be 2, 5, 3 and 7. X would be the variables x and y, and b would be the constants 17 and 24. Remember, the first column of this matrix will contain all the coefficients of the first variables, and the second column of the first matrix will contain all the coefficients of the second variable. So 2 and 3 are the coefficients of x. 5 and 7 are the coefficients of y. If there was another element, say z, then the third column will have the coefficients of z. So the next step would be to find the inverse of the matrix A. Please see the description below on how to find the inverse of a 2 by 2 matrix. So that would be 1 over determinant of A multiplied by the adjoint of A. So the determinant of A would be 7 into 2, 14 minus 5 into 3, 15. That would give us the answer -1. And the adjoint would be 7 minus 5 minus 3 and 2. So finally the inverse would be -7, 5, 3 and -2. When we take the -1 into the matrix, we get -7, 5, 3 and -2. Now that we have found our inverse, let's go back to our formula Ax equals b. We can simplify this formula by multiplying both sides by A inverse. So that would give us A inverse multiplied by A multiplied by x equals A inverse into B. Remember, it should be A inverse into B and not B into A inverse. So when we simplify this, we get Ix equals A inverse B, and then we know Ix is the same as x equals A inverse B. So now that we have isolated our variables, we can put in our matrices. So x would be x and y. The inverse would be -7, 5, 3 and -2. B would be the same as 17 and 24. So when we multiply these two matrices, we end up with a column matrix of order 2 by 1. So when we compare the corresponding elements of the final two matrices, we can conclude that x equals 1 and y equals 3. So that is how you solve a simultaneous equation using the inverse of a matrix. Please see the link in the description below for the exercises on this topic. Attempt the questions and check your answers before moving on to the next video. And now for the tip of the day. The inverse matrix method may seem too long and time consuming initially, but that is because you learned it just now. With time and practice, when you become familiar with this method, it will become easy to work with. Most importantly, this method is more convenient for equations with large coefficients, since all the answers just pop up at the end. So with that, we wrap up this video. Please subscribe to our channel, like our Facebook page and share this video to anyone who will benefit from this video. If you have any questions or any topic that you find difficult to understand, please ask us in the comments below. We are always ready to help you. Until then, take care.